Hello everyone, this is day 2 of our Arduino and TinkerCAD course, and today we are going to be starting with some Arduino circuits which are a little bit harder than the ones we did last time, but still they will be comparatively easy, and I'm also going to teach what a breadboard is. So for the basics of electricity, volts is just like the pressure that you need for current to flow through, and current is the flow of electrons, like water going through a pipe, and the storage is just like a battery or a cell that we use, like this one. And it is really common to use such cells or anything else. And let's get started with today's lecture with our breadboard. So breadboards basically are connected, as you see these green lines are connected together. So if I would give power to maybe only this much, these two pins, this whole line will be powered. But if I have to do it with this won't work, because these are vertically interrelated or connected, you can say. I can connect it like that, and then I can just do that. Okay, wait. Yeah, right. So this is how breadboard works, essentially. And breadboard is a really essential tool for some Arduino circuits, which usually I use in almost all of my circuits. So to get started, we will just take our Arduino Uno, and we will switch from the basic to all components, and then you just have to search here for a micro servo, this blue one or this black one, but the black one needs a little bit more power, so I usually use the blue one. And you can use R to rotate this. So first power will go to 5 volt, then ground will go to ground, which should be black, and the signal can go to any pin on the Arduino except the power ones. So for this example, I am just going to use the analog 0 pin. So the kind of good thing about analog pins is they already do encoding and decoding of the you can say, what do you call that, position, yeah, positioning. So let me just clear this up. Okay, in the void setup, before void setup, we have to define. Now this is a new concept, which is to include some libraries. I'm going to zoom in for this. So you have to just to include libraries, you have to do hashtag include, then this sign, then servo.h. Done. Now in the void setup, what you have to do, but you know what, for the video we will do constant integer, constant integer, what can we set? Okay, you know what, we don't need a constant integer, we will directly start this. Before that, we will add servo, and then servo my servo. Now you can keep any name for this instead of this my servo, but I am keeping it as that. So it should be pin mode, A0 output. Now once that is done, we will give a semicolon. Now we will do What was it? Digital right A0 90. No, 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 no. Wait, digital right. Uh, Everyone, sorry everyone. This was not it actually the this thing the command. It was the servo name, and then right wait right 90. Yeah, yes. Okay, so this was small. Yep. Oh wait. Okay. Okay, so it's not rotating to 90. I think it is already at 90, so we will turn it to 180. Okay, it did not work. Uh, you know, this is actually I've forgotten a few things, so let's start with the block coding instead of that. Okay, so in block coding it is pretty easy. In control we will just go on start. We have to do output. Where is the servo? Yes, rotate servo on pin A0 to 180 degrees. Now this will work perfectly. Anything? Like seriously? Okay, it was A1. Please be careful while doing this. Why isn't this working? Yes, it is working. Okay. Now if we want to rotate it back to its original position, we can do wait 2 seconds and then rotate servo on pin this to 0. Easy. So now if we just click on download the code, I just want to see what this code is that I wasn't able to do somehow with so much knowledge and so many like years of this knowledge. Oh my god, this takes like ages to open. Okay, okay. Now let's see. Okay, so ah, okay. I forgot. I have to do my servo dot attach. Okay, let's start with this again. So servo dot okay. I don't want this code. Okay, so servo should be my servo, and yeah, include the library. And then after that, in word setup, we have to do my servo dot attach. I think the A should be capital. Yes, my servo dot attach A0. Okay, no, the A wasn't capital. I am getting confused. Okay, the servo is now hopefully functional. So now we can do my servo dot write 90. Yes, exactly. That is exactly what I wanted. Now in the void loop we have to do delay 1000. So that is just going to be wait for 1 second. Okay, wait for 1 second. Then my servo dot write 0. It will rotate back. This is what the code won't actually include. So let's see. 90. Why didn't it go back to 0? Okay, that does not really matter right now, but the basic movement of the servo is what is mattering. So well, that is perfectly done. But now let's, I know this session is getting a little long, but you have to bear with it because these sessions will be like 15 or 17 minutes long at max. So today might be a 17-minute day. I am sorry, but yes. So let me teach you if what you should do if you need extra power. In some circuits you might need 18 volts. So it is really really easy. Now it is just the connection of two wires. You have to connect this negative to this positive, and I will keep the common wire to yellow. And now you have these two terminals. Now if we just take out a multimeter. Okay, wait. Yeah. Now if we take out a multimeter and just see how many volts this is, it will show 18 volts even though these are two 9-volt batteries. Because now wait, this is lagging a little, so yeah, we will delete that. Now you can multiply this to pretty much any level. I have made this to 2300 volts till now, but if you want you can just compare this side by side with another multimeter and a 9-volt battery. So I can just directly connect this in this situation. So this is 9 volts, and if we go into amps it is 6 amps. This is also 6 amps. So this is a very good source without exceeding the current and keeping the current same, but making the output voltage of this very very perfect. Now the best thing that you can probably do when you want to do some time pass is just take something like this. In TinkerCAD, not in real life. In real life it can be the most dangerous thing that you can ever do. Okay, so now this will be 36 volts. If we go ahead and measure this, And never forget that you have to color code your wires, because that is the most basic thing that you can do. See, 36 volts, like that's perfect. And this is actually really easy to do even in real life, but don't do it. And if anything bad happens, I will not be responsible. Disclaimer, please. So let's just try a piezo before going. So how can we use a piezo that beeps when we want to? Now in this case we can use an Arduino. Connect the plus to here and negative to the ground. Now the code is really simple. So what you have to do is just go into the code and blocks, and you remember the last time which circuit we had done? We have to do that same exact circuit. So we have to do digital right, digital right, and then it should be um which pin, 7 high in caps. So now if you just do piezo, so I can just do this and then delay. Actually, you know what, let's keep it 1500. Digital right 7 low. Now this will essentially just do one thing, and that is to beep this. So what? Okay, the W has to be capital apparently now. What is like the thing with these simulations? I know it sounds hilarious, but let's just do, instead of 1500, let's do 6000. Okay, wait, I think there is too much current going into this thing. So we can just keep this simple by using a motion detecting, not a gas sensor, a PIR sensor, signal power ground, or a photoresistor, which is even better. So you keep terminal 1 to positive, and then let's add a battery, which should be a 1.5 volt battery. Actually, wait, yeah. Okay, so now this is a basic thing. Let's convert this to two batteries. Yes, now there is finally a sound. Or we can keep a buzzer. Okay, no, there is only a piezo, but piezo is a buzzer in short. So if you just pass on light to this, it will work. But I think I have connected it wrong, because I had been taught in one of my lectures that this thing the terminal 2 may go to positive. Okay, no. Or you can just use some kind of another sensor like the PIR sensor, which is also a pretty reliable source, I'd say. Now this should work. Now this is perfectly working, because if it detects any motion in it, it will it will just start buzzing. Okay, it will start buzzing like this. And this was a pretty fun project to do. So this is a very long video, I know this. Thank you everyone for watching this video. The next video we will start with a few even more advanced circuits than this, because some circuits are way more interesting than this circuit right here. Thank you everyone for watching. Bye bye.